Hello and welcome to another mathematical studies video. I'm going to talk about other functions. The reason for that is that since you're going to have your calculator, you must be ready for any function to pop up, because technically you can graph any function and should be able to interpret a few things about functions. Now, when they appear, you're just going to use your graphic display calculator. This is more or less what other functions might look like. I'm going to go through a few of them. Again, this one here is a polynomial, it's called a cubic function. This one here, which would be a rational function because I have the x dividing. And this one here, which looks special, but it's actually just a rational function. So you'll have to graph them, find intersects, etc. And this will all be done with the graphic display calculator. So let's look at a few important ones. The cubic and the quartic functions. So this one here is a cubic function. It's essentially exactly the same as a quadratic function, but I've added an element with an x cubed. If I take a cubic function and I add an x to the power of 4, I would get a quartic function. This is what a quartic function looks like. I could keep adding stuff and have an x to the power of 5 and an x to the power of 6, and technically they could ask me to plot it and figure out the value, for example, like intersects or other features of the graph of this function. Nevertheless, I'm just going to look at the cubic and the quartic because I think they are a pretty good example of what happens. Let's look at two examples of cubic functions. Here I have them. The red one, f of x equals x to the power of 3 plus 2x squared minus x plus 1. And the blue one, g of x equals x to the power of 3. Now realize how f of x goes up, has a maximum here, has a maximum point. They might want me to calculate that. We will look at this more carefully later on. Has a minimum point here, and then it goes up again. Whereas this one just becomes flat here for a little time and then goes up again. Now, an important thing to realize is that the range of the cubic function is going to be all of the real numbers, unless they tell me that it's not. They specifically tell me, no, by the way, the range is going to be from here to here. So in a cubic function, the range is going to be all of the numbers. Let's look at two quartic functions. Here they are. Now they look very different. This one almost looks like a funny parabola, like a parabola that's been like shaken around a little bit. It's actually a very complicated function. It has a lot of things. Whereas this one here, which is another quartic function, very similar, like it looks very similar, just the minus sign changes it a lot. And you can see how it has this little funny shape here, kind of like a camel the other way around. The range of a quartic function will not be all of the real numbers, because as you can see, clearly here it has a point, and it never goes beyond this point. There's no values of y in this function. So it's not going to be all the real numbers. In this one here, it would be here. The rational functions are actually perhaps the stranger ones. We have a rational function whenever we have an x dividing. Here are some rational functions. In all of them, there's an x that's dividing. So when I graph them, this is what they look like. Now, nothing too particular about this, but there is something interesting. Check it out what happens when x equals 0 here. When x equals 0, what's the value of f of x? Well, there's nothing. But it seems that it's getting closer. Check out here. Again, when x equals 0, it keeps getting closer. Here, when x equals 0, f of 0 is clearly 0. Now, what happens when x is minus 1? Again, I have something funny going on here. It never quite gets to a value for minus 1. And I could zoom out as much as I want. Go ahead and plot it if you want, and I will never get a value. Now, do you guys remember the horizontal asymptote? It's actually quite similar. Vertical asymptote. So this one here you have it again. We can't calculate 1 divided by 0. That's what's going on. When I put x equals 0 in here, I get 1 divided by 0, and there's no result for that. I can't calculate that. So when x equals 0, there's no value. We say we have a vertical asymptote at x equals 0. And here, in this one, we're going to do the same thing. Again, I can't divide 1 divided by 0, so I'm going to get a vertical asymptote at x equals 0. And here again, I'm going to get a vertical asymptote actually when the denominator is 0. So that's going to happen when x equals minus 1. One small thing I have to add about the rational functions. If I have f of x equals 1 over x, I can also write that x to the power of minus 1. This is very important. This one here, I can also write it as x to the power of minus 2 plus x. Get an actual exercise. They ask me to sketch the graph of this function, write down the equation of the vertical asymptote, and find intersections with this other function. So I just put the function in the calculator. Again, here you have it. That's in the TI-84. And I plot it. I have the graph in front of me. And I will have to copy the graph into the exam paper in a nice way. Now the way to do that, remember, is to make sure you pretty much know where this important points are, like this minimum point here, this one here, where it cuts this axis, and you can calculate all of those things with your calculator. For B, now I just look at the graph and realize, hey, hold on a second, which is the one that's not going to work out? It's this one here. There is no value for x equals 0. You see how it goes towards it, but it never quite gets there? That's what's going to happen. So we say we have a vertical asymptote at x equals 0. And finally, to find intersections with g of x equals minus x squared plus 3, all I have to do is plot to both functions. I press graph, and here they are. And now I just go to the menu calc and look for the intersection points. And this will be the intersection points. I have to round them up, so that's why I put that funny sign. Well, thank you very much for watching. I'll see you next time. Goodbye.